Hi, Geometry Honors. We're going to do Chapter 4 in Geometry in a minute, but to introduce the chapter, we're going to do our algebra review. Chapter 4.0 is polynomials, and we're going to make sure you can do any operation with polynomials. Just know that a polynomial is an expression with terms. And those terms are separated by pluses and minuses. Okay, first, a little preliminary stuff that's not super important to me, but the number of terms that a polynomial has gives it a certain name. So you can have 1, 2, 3, or 4 or more terms in a polynomial, and we have a name for it. If it's a single term polynomial, we would call that a monomial. Okay, an example might be like 2x squared. That's a single term. There's no pluses and minuses to it. 2 terms, binomial. Example might be x minus 5. 1 term, 2 terms, separated by subtraction. 3 terms is trinomial. Okay, example of that might be x squared plus 2x minus 4. 1, 2, 3 terms. And then once we get to 4 more, we get lazy and we just call it a polynomial. So we could say a polynomial of 4 terms or a polynomial of 7 terms. Also, the highest exponent is known as the degree of the polynomial, and we have words for that as well. So the highest exponent, also known as the degree. It can get a little more complicated than that if you have different variables in it, but we're not going to do that. So the highest exponent and degree, and we have a name for that as well. So if the highest exponent is 0, we call that a constant. So that's a really simple polynomial like 7. Okay, the highest exponent for a variable is 0. There is none. If the highest exponent is 1, we call that a linear polynomial. So an example might be like x minus 4, because there's an exponent of 1 on the x. The highest exponent is 2. We call that quadratic. So x squared plus 5x. Highest exponent is 2. 3, if the highest exponent is 3, we call it cubic. And then you don't see 4 and 5 too much in geometry, but 4 is quartic and 5 is quintic. And these can mix and match. So for example, if you look at this here, this is a quadratic, because the highest exponent is 2, trinomial. Quadratic trinomial. This is a quadratic binomial, because it's 2 terms, linear binomial, etc. So I'm less interested in the names. I want to talk more about the operations. So I want to make sure we can add, subtract, and multiply comfortably with polynomials. Often polynomials, when you're doing stuff with them, we write them in parentheses. We've already done a little bit of this when we did systems, so this won't be super new. But here's a case where I want to add 2 polynomials. Actually, they're both quadratic trinomials. Now, when you're adding, it's almost like you're distributing a positive 1, which doesn't change anything. So we can just drop the parentheses and collect like terms. So adding is the nicest, because you don't really have to think a whole lot. Remember, like terms means you have the exact same variable with the exact same exponent. So those 2 can combine to be 6x squared, not x to the 4. Okay, negative x plus 2x, that's plus 1x. I'm not going to write the 1, that's unprofessional. Positive 4, negative 7, those also are like terms, and we call that 6x squared plus 3. Generally, we like to write it with the highest exponent, and then the next highest, and then the next highest. So high exponents to the left, lower exponents to the right. That's called standard form. And this is a quadratic trinomial, in case you care. I can also subtract polynomials. All right, so now this is a trinomial subtracted with a binomial. That's okay. We're just going to remember to distribute the negative 1, which you would have anyway. We did this in systems. And now we can combine our like terms. That one has no like term. That's okay. I'll write it first because it's the highest exponent. Negative 1 minus 4 is negative 5x. Remember, we're not changing exponents when we add, subtract. And then positive 2 and positive 5, that becomes positive 7. Okay, so that's the adding and subtracting. And we had a cubic trinomial in this one. Okay, I would like to do a little bit of multiplying. We're not going to divide. That's really an algebra 2 thing. Okay? Most of you know to instinctively FOIL this because we've talked about FOILing with the radicals. So we have to do 3x times x. Now what we have to remember with exponent rules is when you have some variable to an exponent, multiply with another variable to the same variable with a different exponent, we have to remember the exponent rule that those get added. So that's x to the n plus m. So 3x times x, well 3 times 1 is 3, and then x1, those add to x2. That's the first term. Outers, that's a little easier, 15x. Inners, negative 2x. Last, negative 10. And then we combine our like terms here. That should have gone around there. And we have 3x squared plus 13x minus 10. Okay, these can get a little more complicated. I want to make sure you're comfortable with that. Okay, there was one kind of like this on your diagnostic. Okay, we have to make sure we honor the order of operations. It's tempting to distribute the 2x, but that would violate order of operations. This is multiplication. You don't want to do multiplication before exponent. And we have to remember we have to write this twice. This can distribute. So I'm going to call this 2x, 4x minus 3, 4x minus 3. And then this can distribute. This is its own separate entity. Or I can distribute it later. It's fine. But that I'm going to get rid of. Now at this stage, I have 1, 2, 3 things being multiplied. So I can pick any pair to multiply first. I can FOIL these first, then distribute 2x. I can distribute 2x first, and then FOIL. So if I distribute first, I get 8x squared minus 6x. And now I can FOIL these. Okay, I'm going to go fairly quickly for this one so this video isn't ridiculously long. And then I can't forget those last two terms. Now at this stage, I can look for like terms. We have a bunch of x squareds, which I will combine. And we have a couple of x's, which I will combine. Negative 48, negative 49x squareds. 18 minus 4 is 14. Okay, so we have a cubic trinomial answer there. Okay, so we always want to remember just distribute, distribute, distribute. All right, just two more. I'm a big fan of doing area and perimeter problems. So if let's say I want to find the area of the shaded region here, and these are the dimensions. I don't really have units, but let's just, call them inches, I guess. If I want to find the area of the shaded region, I can find the area of the big rectangle and subtract out the area of the small rectangle, and that will give me the area of the shaded. So the area of the big rectangle is a 10 by 4, that's a 40. The small rectangle is a 3 by 2, which is 6, and I have a 34. Now, I'm more interested in doing these with polynomials. So for our last question in this video, I'm not going to have the dimensions be integers, I'm going to have them be polynomials. Now, as scary as this looks, it's the same procedure. I'm going to find the area of the big and subtract the area of the small. So the area of the big is 3x plus 5 base times height as 2x minus 1. The area of the small, base times height, is 6x times x minus 3. So I'm going to FOIL this, distribute this, I'm going to make sure I just subtract them. So the area of the big minus the area of the small. Okay, I'm going to go fairly quickly here. I FOILed that kind of in my head. I'm going to distribute that negative carefully. Notice how I distributed that negative 6x properly. And now I'm going to look at my like terms. This is convenient that these two cancel. 7x and 18x is 25x, and then minus 5. So I don't have a number answer, but I have a polynomial, a linear binomial answer. All right, so good luck with your worksheet. Make sure you hand it in by the end of the period. Thank you.